and get that going. So that's when the day one agenda for developing on AWS. Day two, we're going to switch gears and we're going to start talking about data stores because, right, applications, data, that kind of thing. And then we're going to talk about serverless. We're going to talk about options for managing serverless, which is what API Gateway really is, right? For basically publishing publicly consumable APIs, you can meter and cache and all that. And then we're going to talk about event-driven solutions with Lambda, which includes, by the way, step functions, which is an orchestrator for Lambda functions. If you've never worked with Lambda before, Lambda has a 15-minute execution limit, which probably doesn't matter when you have an orchestrator that can just chain a bunch of Lambda functions together. Event-driven architecture, by the way, is basically the core architecture concept that you use with serverless. And it didn't really take on back in 2014 when Lambda first came out and the concept of serverless first came out. But people are really trying to get away from virtual machines and even containers to a certain degree. I know people are hot and heavy on Kubernetes, of which I'm a specialist in Kubernetes. But I got to tell you, serverless is really starting to appeal to people. And then day three, we're going to talk about some of the adjunctive services that can add what I like to call abstraction layers in between your applications. Like if you need an application that needs to dump 1,000 messages a second or something to, or 1 million messages a second to another application, you could put that in a queue. For example, these are not new concepts. They've been around for 20 years. But the simple queuing service and the simple notification service, especially if you want to do fan out. So the simple notification service will do message duplication if you need to duplicate a message out to several other services. Then we'll do a lab on that. And then we'll talk about caching, talk about developing secure applications. And then at the very end, you're actually going to build an end-to-end application. One thing to note about the labs, which you may have noticed, is that there's about 2 labs a day, right, in each of the course content. One thing to note about the labs is that they will give you the entire solution right off the bat. And if you have never worked as a feature programmer on a team, then I would say that you probably want to just go for the solutions, look at the solutions, digest them, own them, understand exactly what the solutions are doing, and then that's going to be your lab experience. If you're a feature programmer, though, and you're comfortable with the language in question, then you're going to do something a little different where you're actually going to try and figure out how to, define the object, call it, and execute it, right? So just so you know, your experience level with the labs is going to vary based on where you're at, but just know that they will actually give you the solution. So if you're nervous about how am I going to figure this out if I'm not really good at coding, don't worry, you get some help. And, I'm here to assist. Oh, Adam, by the way, Klaus, go to killer.sh if you want to know about how to prepare for the CKA exam. So killer.sh is a great resource. Let's see. So that's going to be it. We're going to basically be running through about 14 modules. Really, honestly, it's 12. The first one and the last one don't really count. And then we're going to do about 6 labs. Now, as part of being an employee with Booz Allen and taking a class with WebH Solutions, which I am a trainer for, so WebH has been partnered with Booz for 20 years. And I pretty much do 90% of my work for Booz Allen, actually, through WebH. Note that you are going to get some test prep resources that you normally wouldn't get if you had taken just a plain AWS class. So I have all of the core certifications and one of the specialty certifications. And oddly enough, I just sat for the machine learning specialty exam on Saturday. It kind of melted my brain. So if I slur like I've been drinking, I haven't. Machine learning just took it all out of me. So I just did the exam. So I know a lot about the certifications and about how to get them and achieve them. And I usually take all of them once every 2 years, even though I don't need to. So I'm going to talk about that. Now, our normal methodology is that the end of the day today around 4:30, and this is going to happen at 4:30 tomorrow. It's going to happen at 4:30 on Wednesday. I'm going to stop teaching about the AWS content, and we're going to roll over to some certification content. Now, today it's going to be super easy. I'm just going to talk about the certification, give you a feel for what the certification includes. And that's going to be that's just included as part of the class because you're taking an exam prep class. For those of you, by the way, who are not interested in certification, at 4:30, we're done. So you can go at that point in time. I mean, I'd love for you to stay, but if you're like, I don't want the certification, 4:30, you're out. Go, right? We're done. But for those of you who are interested in taking the certification, and if you work for Booz, I would highly recommend that you be interested because, you know, Booz loves certifications. I'm going to do that at 30 minutes of every single day. Okay. Other structures that you should be aware of. We're going to take a break pretty much every 90 minutes. Sometimes it might be in the middle of the module. Sometimes it's going to be at the end of the module. Sometimes it'll be associated with the lab. We're going to take a break. That's just the way our brains work. Every 90 minutes, I'm going to give you breathing room so that you can actually assimilate the information we've covered. At noon, every single day, plus or minus 5 minutes, I'm going to stop talking and we're going to go take lunch. Why? Well, because we're at that point, we'll be 3.5 hours into the day. You know, you're going to need some time to just assimilate all the information. And then we'll usually come back at 1:05 or 1:03 or some other odd time. And then we'll go until 5 o'clock, but just know that we're going to take breaks in there as well. So sometimes it's 2 breaks, sometimes it's 1. It just depends on how you all are doing. If you're all checked out and not talking to me, I might take more frequent breaks because I'm like, they're not really engaged, which is totally fine, you know, because I know we're all a little zoomed out from the pandemic, right? Other things to note, other than the fact that we're going to take, you know, at least 1 break in the morning, take lunch at noon, take a break in the afternoon, and that technically we're done with the official content at 4:30, but we'll stop the exam prep at 5. The other thing to note is that, you know, we've all been working from home for about, what, 18 months, 2 years now? I guess it's 2 years. God, it's 2 years. It's been 2 years. That's crazy. I last traveled in January of 2020. So what that means is that you're in an environment where you're used to being in front of the computer and you've kind of built your habits up, right? Now, I'm going to be talking, and I'm not going to be talking in a monotone voice and ask you to turn your heat up and be like, this is S3. S3 is this amazing object storage service that, and this is not going to be marketing speak, right? I'm not going to talk in a flat monotone voice. The reason I say that is that you have grooves or habits of checking out, and that's fine. I'm going to cry silently like a champion by myself after class ends if you're not paying attention to me. But do know that you probably want to get a notebook or something and just, or even a mind map thing, and just like take notes, take synthesized notes, draw pictures, doodle something, because it's going to increase your retention ridiculously. And especially if you're going to study for the exam, it's really going to help you. So recommend that you do actually preferably handwritten notes, because for whatever reason, all the studies show that the handwritten notes tend to make all the difference. But just know I do actually recommend that you take notes for today's the next three days. Just kind of map everything out. Okay. By the way, we'll get to this in a second, but does anyone have any questions for me? Okay. Do we need to be signed up for the labs already? Austin, let's see. I'll talk about that in a minute, and there's a whole section on it. But you should have gotten an email from it's like webage.quicklabs.com. And what it is that you should have gotten an email. We sign you up for the private AWS labs. Notice that distinction I made. I said private AWS labs. There's actually a series of public AWS labs, which is through amazon.quicklabs.com or www.quicklabs.com. That's the public site. So just know that when you're already registered for the private AWS labs that are part of this course, you may not know your password, but you'll just do forget password. It's always your Booz email address, unless you register with a different email address, which we'll look at in a second. So I'll make sure everybody use their Booz email addresses, right? So don't worry, Austin, we're going to get you signed up, but you should already be signed up for webage.quicklabs.com. I mentioned amazon.quicklabs.com because that's going to be part of the test prep material. So just, briefly remember that I said that, and we'll talk about that later. Okay. All right. Let's see. Usually we don't do this just because there's not enough time to do this, just to be frank about it. And I've already asked you a bunch of questions, which you've all posted in there. I guess the one thing is that, I just want to make sure that everybody understands that we're going to be doing developing on AWS. This is about how to interact programmatically with AWS services and how to architect them and consume them as a developer. I know that usually is a surprise to people, but not as solutions architect level, but just as like a systems architect level, right? How do I, put SNS and SQS in, and how do I use step functions to orchestrate Lambda? Sometimes that's a surprise to people. And then, you know, we're going to be using one of the 3 languages. So if you do the labs, you got to be comfortable with one of those 3 languages. So again, just checking in now that everybody's here. Is everybody in the right place? Okay. I got 2 yeses, 3. I'm going to assume the 4. Okay, good. Good. All right. One thing that I usually get asked almost immediately is that people are like, hey, can I get access to the slides? Man, I would email you the slides directly if Amazon wouldn't fire me. So I'm an Amazon authorized instructor. I signed some, you know, NDA and gave away my firstborn, but they will not let me give away the slides. Now, that being said, you have access to like bookshelf.vitalsource.com or online.vitalsource.com. You should have gotten an email that has a license code in it from, I think it's like gilmore.ca. I actually typed that in the chat because, you know, why not? Should be gilmore.ca. That should be somewhere in the email that you use to register for this class, which is typically your booze email. That has a license code. You're going to go create a login and then you're going to redeem the license code that's in the email, right? So just know that when you do that, you will get access to a digital copy. Let's take a look at what this looks like so you can see it. So for example, this is mine and it's ridiculous. So just ignore it for a second because there's a lot here. But when you get logged in here, it'll say something like my books after you like redeem your license code. And I don't think I even have a redeem just because I guess as an instructor, mine is a little different. But what happens is that once you redeem it, it'll show up in one of your groups. And so, for example, you'll have like a developing on AWS group, right? And in here, you won't have a bunch of different languages because I, you know, right, just the way it is. But there's a student guide, and let's see, lab student guide English borrowing limit reached. Really weird. Huh? Never seen that before. I guess I borrowed some items. Anyway, what will happen is that you'll see the slides that I'm about to go through. So if you're worried about having the slides or the notes, not only will you have the recording, but you also have access through a student guide. My apologies. There's obviously some kind of error going on here where it says that I've borrowed too many books. I don't know what that means exactly, but this is where it's going to happen. Is it's going to happen in Vital Source Bookshelf is what you're looking for. Okay. That's it. That's how we get started. Does the access to the courses expire? Yes, Billy. You can print those out, by the way, into PDF form. AWS does not support that. Please be careful with that PDF file, by the way, because it has a fingerprint for your account on it. So when you print it out, it gets watermarked. Other things to note is that the lab access, which may also be worth showing you. So I'm just having all kinds of technical issues today. There we are. Just so you know, is that you're going to get lab access and yours is going to look a little bit different, but this is webage.quicklabs.com. And you should have an email somewhere in your inbox for this as well. What will happen is that when I last looked at this course, I don't think your access expires until April, which is pretty cool. So Amazon shifted it so that you have access to the lab environment for like 3 months. You have access to the books for usually about a year. And after a year, they're pretty out of date anyway. So, you know, take that with a grain of salt. Okay. So I hope that answers your question, Billy. A year for the books, 3 months for the lab access. And so you can come in here and actually take the developing on AWS class many times. Usually after about 3 times, it kind of errors out. So, and then just to mention this, as a booze employee, you're going to have access to the public side, not the private side, but the public side of the AWS catalog. And you have unlimited access to that by virtue of taking a class with us and being a booze employee. I'm going to cover that later, but there's about, I don't know, 80 public AWS labs ranging from super simple to complex. You're going to love those because for those of you who don't have an active project involving AWS, we're going to give you unlimited access to a bunch of little micro projects with AWS. So it's going to be fun. We'll talk about that this afternoon. Okay. All right. Let's move past module 1. Okay, checking in. Are we good to move forward at this point? Does anyone have any lingering, burning questions that are like, man, I really need to get this answered before we dive into this? All right, let's do it. Okay. All right, so let's talk about cloud. Let's talk about some scenarios, a little overview of the infrastructure, just a reminder in case you haven't seen it for a second. And there's some stuff around the foundational services. Okay. Cloud computing, like, what is it, right? Because it's like, didn't we have other people's servers? Because that's the joke, right? Back in 2005 or whatever. 2006, by the way, is when AWS was launched. Does anyone, by the way, know the first service that AWS launched? And I'll give you a hint, it wasn't S3. Nope, Adam, it wasn't EC2, although I gotta tell you, S3 and EC2 were super close. Days, if not weeks within release. It's kind of weird, actually, but the first service that they released was actually SQS, the simple queuing service. Isn't that weird? I would have thought like EC2 would have been the first service, but SQS was actually the first one, then S3, and then SQS. It was like all within like weeks, right? It was just there it was. And of course, but nobody wanted to use it because it's like, are you kidding me? With a credit card and no agreement and no security certifications, we're gonna like put our data on AWS. But I gotta tell you, it was great for proof of concepts. I mean, Heroku was out in 2005, but they were only offering really application hosting. They weren't really offering, and a bunch of people were offering operating systems, but nobody was offering services, and nor were those services fully like API defined. Like, you may know this, but Bezos, way back in like 2000, 2001, wrote an email, said that, hey, everybody better be publishing their services through APIs or get out. Like, he's like, I love you guys, get out. Like, this is the future, which was a great bet because 5 years later, they're publishing an API driven infrastructure, which turned out to be basically how everybody was going to do it at that point in time. And all the ecosystems that have popped up out of that. I mean, I'm not necessarily an AWS fanboy. I do like them, but I mean, they pretty much changed the industry. Kind of looking forward to what the next disruptive industry is. So here's some models for cloud computing. And I like to think of them more of like top to bottom, right? So infrastructure as a service, which is where you get like, for example, a virtual machine. A virtual machine is infrastructure as a service. If you're gonna like launch a database, but you're not gonna get access to the underlying virtual machine, like the Linux box or the Windows box that's hosting the database, that's more like platform as a service. That's where you're consuming things like ActiveMQ and Kafka and other kind of services like applications, but you don't have access to the operating system. So that's what a platform as a service. You get access to the platform, but you don't get access to the core infrastructure underneath it. And then you've got software as a service, which honestly, all of us are familiar with because we use Gmail and we use Office 365. And all we're really doing at that point is consuming a high level application, not even like a database repository or like a streaming repository or a queue repository. I mean, not like a data application. I'm talking about something even higher, like email, right? Spreadsheets, that kind of thing. So, from a hosting perspective, just to share this, from an application hosting perspective, I want you in your minds to think of these as virtual machines, containers, and serverless. You're like, what? Just follow me for a second. So you got virtual machines, so you got an incredible amount of control and a huge amount of responsibility. That's infrastructure as a service. With software as a service, all you do is put your Python, your Java, your Go, your .NET, your whatever into a packageable format. You answer a few questions, and Amazon takes care of running all of the underlying infrastructure. You have zero flexibility. I say zero flexibility. You have a minimal amount of flexibility, and you've got minimal amounts of security responsibility or operational responsibility, right? You have very little. Software as a service versus infrastructure as a service. Then you've got the middle ground with containers, right? Or database applications or a queuing service or any other kind of mid-tier data hosting application. You don't have access to the infrastructure, but you've got more control than you would if you were running software as a service. Containers fit here, but only if you're running containers in a managed manner, which means because a lot of people don't know this, but Docker containers, as an example, require an operating system to function. So there's still virtual machines when you run containers, but if you're using a managed option, you're not responsible for the underlying operating system, meaning like a serverless option, like a la Fargate. If you ever heard Fargate with AWS, right? And just so you know, almost all the like hyperscale providers like Google, Microsoft, AWS offer a container option at the PaaS level where you don't have to manage the servers. Okay. So from an application hosting perspective, meaning I'm hosting an application, virtual machines, containers, and serverless are your kind of three levels. So think of that as IaaS, PA, PaaS, and SaaS. Okay. So fix that in your brains. Now, of course, AWS has answers for this. If you want virtual machines, it's EC2. If you want containers, it's either ECS or EKS, which is the Elastic Container Service or Kubernetes service. And then for serverless, there's really only one option, which is, Lambda. So which we'll talk about. So if you're like, well, you just rattle that off, don't worry. You too will rattle it off by the end of the 3 days. The other things that if you took Cloud Practitioner, AWS wants you to know about the 6 advantages from a general industry perspective is that typically you don't have to invest in hardware anymore. Every time Amazon gets better at hosting applications, they're going to pass on savings to you, which is just a commitment they make. And it's true. I mean, I can't tell you how many times they've lowered prices on S3 or made faster virtual machines that are cheaper. It's like, huh? I hate the lower left one. It says stop guessing capacity. That just cracks me up. First of all, we're all guessing about capacity, right? Because the vendor is giving us estimates based on common use cases, but no one ever really knows what the application performs like until it's launched into production. Because also customers use applications in ways that we don't expect, especially if you're dealing with honestly like battlefield level applications or anything that has like real-time environment feedback, like space telemetry, like that. I don't even know that. So a better phrase would be not only stop like guessing capacity, but fix your bad guesses easier. Because if you don't have to worry about the hardware boundaries, like how many like physical boxes do I have to host a 1,000 box application? If you don't have to worry about that because Amazon's taking care of that for you, it's not that you stop guessing capacity, it's that you fix your bad guesses. I know that nobody who can hear my voice has ever gotten a document that says we're going to have 10,000 users a second on our website on day one, and it's like 1,000. Or they say 10,000 and it's 100,000. I know nobody's ever had that, where the customer gave you wrong requirements. So anyway, fixed bad guesses is really what that one is. And then speed and agility are good because you don't have to worry about hardware boundaries. So you're not running cables under the floor. You're not dealing with any of the procurement stuff because AWS is. Stop spending money on data centers. I think we kind of covered that already. And then going global in minutes. So between Global Accelerator and CloudFront and then Route 53 DNS, and then all the backend data storage replication, like, Aurora will do global replication, DynamoDB will do global replication. Like you can replicate your data stores now really easily. So you can go global in minutes now. It's a very different world actually from what it was. It's really easy for you to, for example, scale a website to be a static website in particular to be scalable across the entire world within a couple minutes. It's awesome. And then there's a ridiculous number of services. So I like to joke about this is that you should probably go out there onto the console and look for a service because, they probably have it. Like, let's put that to the test a little bit because what if I'm just making that up? Hey, don't worry, we're going to come back to you. So, all right. So, it's a great way to start a sentence. Just so you're aware, Amazon has recently updated their console and I feel weird about it. But anyway, so for example, someone rattle off either in chat or voice an application that they, like a PaaS application or a database or whatever that they use frequently. What's something you use a lot? Let's see if AWS has it. No? Databricks. Well, Antonio, that's not fair. Databricks manages EMR, right? So EMR is Elastic MapReduce, and it also runs Spark. So yeah, so Databricks is an EMR manager basically. Oh wait, I just went to Elemental Media Store. That's not what I wanted. It's this managed Hadoop framework. So Databricks manages, or basically offers managed EMR. That's what they do. So they're a great company. I enjoy working with them. Let's see. Postgres. Well, if I was looking for Postgres, that means I'm going to look for RDS, right? Let's see, Adam. That's a great question. So what about NoSQL? Because Postgres is an SQL database, which, you know, I think is really extensible. But what if you were looking for NoSQL? Well, NoSQL gets a little sick, actually. So they have DynamoDB, they have DocumentDB, they have key spaces. They also, by the way, which, I'm sorry, I'm not explaining that very clearly. DynamoDB is based on a Dynamo paper that they published in 2001. The open source analog is RIAC, R-I-A-K. DocumentDB is MongoDB, basically compatible. Keyspaces is Cassandra compatible. They also have Elasticsearch, which is called Elasticsearch, or actually it's now called something else like OpenSearch or something like that. And then they also have Neo4j, which is a graph database. It's under the guise of Neptune. So they have a ton of NoSQL options, some of which are not listed here. They also have managed Kafka. They have ActiveMQ. They have RabbitMQ. They have Redis. They have Memcached. If you're looking for an open source data store in particular, they probably have it has a managed option. So just be aware of that. So the main point of all that was just to say that there are a ridiculous number of services that they have. If you're looking for satellites, by the way, because you're like, hey, I need to communicate with satellites, yeah, they've got that. If you're looking for virtual reality, they have Sumerian, which is used for that. If you want to, test all the QA, all your mobile devices in the cloud, they've got a mobile farm. What are other cool things they have? Oh, Bitcoin. If you're like, hey, actually, let's go for the underlying technology. If you're like, hey, I want to know a little bit about blockchain, they have managed blockchain. Now, are most of us going to use these services? No. Honestly, most of us are just going to use the core services. Let's see, quantum, they have quantum computing. All right, so I know it feels a little bit like some kind of weird flexing, but it's not meant to be. Just know that they have a ton of services out there. So the main thing that most people use is related to application hosting, because most of us, especially at enterprise level, are hosting custom applications. So just know it's probably going to be storage, networking, or compute. And they do have a bunch of adjunctive services, like if you want, for example, mobile or web app like user IDs, they have Cognito for that. If you want, notification system, they have SNS. If you want a queuing system, they've got SQS. They also have ActiveMQ. There's just a ton of options out there. So this is like a little bit of a toe in the water for the 300 plus services that they have. Now, I'm going to forewarn you. This doesn't happen a lot in this class, but some of the services are meta services. What do I mean by that? CloudWatch is the monitoring service for AWS. It has 11 sub-services at last count that are in of themselves major services. So just know that we're going to talk about some things that are going to be just simple services, like DynamoDB is a pretty straightforward service. But some of the services are just like entry points into like 17, 20, 11, like other macro services, which can be intimidating. So we're just going to take a little bit at a time. Okay. Here's some of the foundational services we're mainly going to be interested in. So everything related to networking, storage, compute, data hosting, some security. That's it. So think about your laptop. It's got CPU, so that's compute. It's got the disk, so that's storage. Forget memory, because that's like storage also to a certain degree. And then we got networking, right? Because wireless or cabled. And then think about the applications you usually use for an application. Usually have some kind of data repository, a data store. So like a database application. And then there's the actual application services themselves, like notification, monitoring, that kind of thing. So we're going to talk about some of that. One other thing to note, and this is good to know for the exam, is that Amazon wants you to use their managed services because it's going to save you scalability, time, money, operational overhead. In some cases, the service is going to be a little bit more expensive than if you rent it on your own, but it's going to cost you less time. This is Amazon's game. This is why they're at $54 billion of yeses, right, annually in revenue for AWS, is they're trying to take all your operational concerns off your plate. And again, I know security and control and all that might negate that, but that's what they're trying to do. Here's a sense of all their platform services, like things that are over and above, like from, infrastructure as a service. Although I would argue that a lot of these are SaaS. It just depends on kind of what you're trying to accomplish. So we got databases, we've got analytics, we've got application enablers or application integration, like abstraction layers. We've got a bunch of developer tools: code commit, code build, code deploy, code guru, code artifacts, code pipeline. It's, they went a little crazy with the codes. And then it says mobile services, but just also be aware that API gateway is also, and Cognito are for any web application. Okay. At this point, any questions? Do you get a sense for there's a large number of services out there for AWS for applications? Okay. Other things that AWS wants you to just remember is that you're either all in on cloud, you're all in on your own data center, or you're hybridized. Most of us are hybridized. If you're an enterprise that's been around since before 2012, you are most likely hybridized. If you are a startup that started from 2012 forward, typically you have no infrastructure. You are all into cloud. Now, whether you're into AWS or others is up to you, but I don't know of a single startup, unless they have some kind of hardware or security requirements, that isn't all into cloud. They're not running in their own data centers. One thing to know is that a lot of migrations to the cloud can either have you like just sticking it in the cloud, tinkering with it and sticking it in the cloud, or completely refactoring it and sticking it in the cloud. And so this is just an example where, you can take a monolithic application and you just dump it onto AWS, right? So in other words, you start moving some of your core services, your core business processes over to AWS. This is a very common scenario. Microservices is kind of a big kind of evolution that's been happening. By the way, how many of you are either work with or have created microservice applications? Raise your hand or give me a thumbs up or something. Good. Then is that what you're doing is you're taking a single Java, whatever code base, doesn't matter what language it is, that has a bunch of business concerns in it, like billing, inventory, messaging, and you're taking that out and you're splitting that out into a bunch of separate code bases, which are smaller services that are independently deployable. But now, customer profile is an independent application. Can you compared to order management or whatnot? So here they've got file ingestion and file processing, and they've got notification. Those are all separated into separate concerns now. That's what microservices do. And now they all talk to each other either through APIs. Well, it's really APIs. And now everything's independently scalable. So if billing gets overloaded because everybody needs to change their credit cards, that's not going to kill the presentation layer, which is sharing the website per se, or the streaming portion if it's sharing videos or files or whatnot. So, when you go from a monolith, you're basically separating it out into separate code bases that are independently deployable, independently scalable, and independently talk to each other. And this is going to give you a lot of agility, a lot of independence, at the cost of a little bit of complexity, sometimes a lot, depending on how complex your application is. But now you get to use whatever languages you want, as long as your APIs are contractually published and adhered to, right? Changing APIs on other applications, adding to them is fine, mutating them is a problem, right? So there's some assumption that you understand that microservices architecture is basically more and more prevalent when you use the cloud, because you want that kind of independence, and the cost of that is a little bit of complexity, or a lot, depending on how your infrastructure is working. So remember, and I just kind of said this a moment ago, is that when you have separate components that now used to make up your single code base, but now you've separated that out into let's say 20 different applications, you've got this amazing independence, but now these applications are all talking to each other through these contractual interfaces, these APIs. So if you break the API, if you change it in a way, you're going to break it for all these applications that are relying on it. So make sure that you do so in a very like cogent, communicative manner. Try to add to APIs, try not to change existing APIs. So now APIs are awesome, by the way, because if someone needs to get to the customer database, they have to go through the customer profile service. They can't go directly to the database. They need to get to the billing database, they have to go through the billing service. They don't go directly to the billing database. So just know that you're actually hiding whatever technology is happening on the back end. And you might say, but Michael, why can't I just go straight to the database? It's more efficient. It is more efficient, but if you wreck that database, you're going to break the service and it's not your service. You're probably just the, I don't know, security check for billing, right? So we don't want you messing with that database. It's their database, not yours. Other practices other than using APIs to communicate with your microservices components, and of course, creating independently coded and independently scalable components for microservices, is that we really want them to be stateless. So your services are stateless, your microservices are stateless, but there's obviously a data store typically on the back end. And so there's a lot of decoupling there, but nobody else can get access to that data store unless they go through that service. Or there even could be a data access service that's part of the customer service, like maybe a separate piece. Just depends on how you want to approach it. Now with serverless computing like Lambda, Lambda fits in well with this kind of scenario because you're asking it to execute a task, it runs the task, and then it stops when it goes away. So there's not a 24/7 running operating system sitting there just eating costs when you're not being used. Serverless computing, you only pay for what you actually use. With infrastructure as a service like EC2, you pay for what you ask for. So if you ask for a 4-processor 16 gig machine and you start that machine up, guess what? You pay for that machine for as long as it's up and running. Lambda doesn't work that way. Lambda basically says, if you want to run 1,000 code executions for 30 milliseconds, you pay for 1,000 times 30. That's it. Once that thing's done, it shuts down. I'm like, well, Michael, how does it respond quickly? There's a whole art and science to how Lambda is kept performant. But you're basically just running code when you run Lambda. You're not running any servers. AWS does all that for you invisibly. It doesn't really charge you for it. So if we blow that previous slide up where we were going from a monolith with a single code base running on a single system or multiple systems down to microservices, here, if you look at the left-hand side, you've got a user that's over here subscribed to a particular topic. So in this particular case, a user is subscribed to a topic. And what happens is that, let's say that a file is basically dumped into this thing. And that puts a message into a queue, and then the file is processed. And then what happens is once the file processing is done, it sends a message over to the user who subscribed to the topic. And then on a separate plane, what happens is that the file is pushed or outputted to S3, and then the user is granted access to the published file through a separate work path. So here, notice that there's, and let me highlight this in a different color just to make sure I'm being very clear about this. This is a Lambda, and it could have started with an S3 bucket up here. This message is stuck inside of an SQS queue. This could be another Lambda for file processing, assuming that it's within the 15-minute time frame. This is another S3 bucket. This is the simple notification system, which, by the way, this could have been the simple notification system as well. And then, this is just sends an email to the user. So whatever system that is, right? So notice that with about 4 services, with a couple of instances of each, you've got an entire workflow. I ran a video company, by the way, back in 2014 that ingested mainly cat videos. That was not the intention, by the way, but it was weird. Why are people so fascinated with cats? Anyway, moving on. So the whole service had no servers attached to it. and it scaled to, billions of requests per month, right? Sometimes, close to 1 million a day. So this kind of thing can easily be done with a completely serverless kind of microservices architecture, but this is event driven. So meaning someone does something which triggers a response, which triggers another response, which triggers another response, which triggers output, which triggers something else. So this is an independently, like this is going to repeat 1,000 times if someone uploads 1,000 files into that S3 bucket, right? So a lot of this you might have to end up writing yourself, but just to say this, AWS is trying to make it so it looks a little bit more like this, because I kept alluding to the use of services here, right? Where instead of you having to handle all this yourself, maybe with code or with Lambda functions or with your own hosting, AWS is willing to put services in here that will allow you to orchestrate and string all this stuff together. So just know that all these integrations can happen really easily inside of the AWS ecosystem. You don't have to code all this up, right? I mean, you have to code some, but it's really easy to do. Let's see, Billy, you were asking, is there a minimum amount of time you are charged for the services? Do we need to know the limits for the certification? So numbers that change a lot, such as billing and like performance metrics, Amazon will never test you on. Because, I mean, they change all the time. Like, just to say this, like EC2 used to charge by the hour. And now sometimes they charge by the second, but it depends on which operating system it is. Like if it's Red Hat, they can't charge by the second. But if it's MS SQL Server, which is also a licensed operating system, they can do that one by the second. So it's really strange. So things that change like a lot, like billing and metrics, they don't ask you to memorize. But they'll want you to know, for example, that that the message size on SQS is 256 kilobytes, or that a row in DynamoDB also is limited to 400K, right, kilobytes. So they want you to know stuff like that, stuff that doesn't really change a whole lot, or that the execution time for Lambda is 15 minutes. Now that changed once 5 years ago. It was 5 minutes, and it changed to 15 minutes. So stuff like that they'll expect you to know, but not billing and performance metrics. So I kind of mentioned that there's this evolution of where they want you to go from like a virtual machines to a container. Ignore the word task. They put task in there because that's what they call it in ECS. It's really a container. And so they want you to go from a virtual machine to a container to a function, like a serverless function. And they want you to move from like a lot of control in the hardware, right? Very limited access to the platform, and then just control the runtime. So they're constantly kind of like trying to get people to go towards the right because they want to eat the operating system. Now, you have to use the use case that makes sense for your business case. If you have to have control over the operating system, then you're going to use EC2. If you're like, I don't really want to go on full on serverless and do event-driven architecture, I still want to host applications, then you're probably going to go ECS or EKS, right? If you're like, hey, event-driven architecture sounds great, let's not run any servers. Lambda's your friend. Any questions about that before I move forward? I know there's a lot of assumptions that they make about what you know and don't know about microservices and about the 3 layers of hosting. So please feel free to ask any question. Justin, if you look for gilmore.ca inside your email, there should be a license code to redeem to get online access to these slides. Plus, I think there's speaker notes here. So you should be able to get access to all of this through that. But it's online. You can print it out to PDF, but you don't get access to the PowerPoint slides. I wish I could give them to you, but I can't. I have an agreement that says I will not share the slides. By the way, the speaker notes on all that stuff are in here as well. So if there's, there's probably additional items in here. Sometimes they pop up on here and I'll cover them, but most of the time I'm going to go over and above whatever's covered on the slide. So let's see. Well, we go over more use cases between ECS and Lambda, like making decisions to choose between the two. So Antonio, it really comes down to this. if you're using containers and you want to run a 24/7 application that runs for more than 15 minutes, then you're going to use ECS or EKS. If you are doing event-driven architecture and you have one-off little pieces of code that you want to run and they don't run for more than 15 minutes per execution, then you're going to use Lambda, right? So that's really the distinction. Other than that, I mean, the use cases are relatively vague because you can actually use them for both things. It just depends on whether you're really good at event-driven architecture and can work around Lambda's 15-minute execution limit, which is what step functions is for. Well, so we're going to talk about that. Or whether you're more comfortable with containers, you need 24/7 application, you know how that functions and want to host it, right? So we are going to get more into that, but I don't know that they draw a very clear line. So when we get to the at the end of the Lambda set, if you're like, I really don't know when I would use one over the other, let me know and I'll wax on it a little bit. I'll give you my perspective, a little deeper perspective, if by the end you don't know. Okay. It's a good question. Okay. All right, so let's talk about Amazon's physical locations, because Amazon, by the way, has busted out the physical locations in the last 2 years. So previously, they ran data centers, which were put into clusters. These clusters were called availability zones. Clusters of data centers were called availability zones. Availability zones were then themselves clustered together to make up regions. So it's funny because a region, like let's first say Virginia or Oregon, that's just a geographical area that has a bunch of what they call availability zones inside of it. Now, the reason this is significant is that the availability zones themselves are clusters of data centers. So it's like a region is a meta cluster and an availability zone, of which there's at least 2 in every region. Usually there's 3. That an availability zone itself is a cluster of data centers. So it's like a region is a cluster of clusters and an availability zone is a cluster. Really weird concept. What's funny about that is that, you know, the availability zones are like internet and power independent from each other. So hold on one second. Wow. My vehicle's warranty is expired and I need to extend it. So I'm just kidding. I was just like, why is that popping up on my phone? The thing that's interesting here is that the availability zones are independently like connected to power and independently cooled, and they have high-speed interconnects with all of the other availability zones inside of a region. Now, on a map, this is going to look like, you know, GovCloud East, GovCloud West, California versus, you know, Virginia, Ohio versus Oregon, South America, Sao Paulo, like they're all over the place. And as a developer, you might say, well, Michael, where am I going to host my applications? Well, this is easy. This is actually easy to figure out. You know why? First of all, you're typically told where to host your applications. Like for Booz, because of most of your contracts, you're going to host it in either GovCloud East or GovCloud West. Which one are you going to choose? Where are your customers? If most of your customers are, you know, the Eastern Seaboard, you're probably going to be in GovCloud East. If a lot of them on the West Coast, you're going to go GovCloud West, you might end up using both. The other thing that might happen is that you might say, well, services, maybe some services are available in Virginia that are not available in Ohio. That's on the, obviously the public infrastructure, so the private sector. But usually with GovCloud, just so you're aware, services are available equally on both sides. Although GovCloud West came out first, so sometimes things hit there first before they hit GovCloud East. But to Adam's point, you know, multi-region failover, in general, a good idea, especially if you have any DR requirements at all. Availability zones within a region are typically within 100 kilometers of each other, which most people don't like for DR requirements. So it just depends on what your limitations are. In other words, they're no further than 100 kilometers. They could be closer. So yeah. The other thing is that costs, GovCloud East and West don't really have a price difference, but if you're in the private sector in the public infrastructure, like California, Oregon, whatever. Just so you know, every continent typically has one region that's more expensive than the others. So for example, if you use California, which is US West 1, it is about 10 to 20% more expensive than any other region in the United States. Germany is typically more expensive than any other region in the United States, although they're kind of flattening that. It used to be that Tokyo out on Asia Pacific, APAC, was the most expensive of the regions just because land and power were more expensive. But for Boost, you have a little bit more simpler kind of setup because you just need to worry about working out of GovCloud East and West, right? So, all right, a couple other things. Virtual machines plus things that help virtual machines sing, which is what autoscaling and load balancers are really, right? They help manage traffic and help them elastically expand and contract. We are, going to talk about EC2 because this is where you get like this is where you get your virtual machines, right? Ranging from really like small test machines to like they've got bare metal boxes out there that have 24 terabytes of RAM and 448 processors. That's a lot. That's kind of ridiculous, honestly. But bare metal machine, put your own hypervisor on it if you want to. You can stop an instance if it's got all the right conditions. You can actually hibernate it if you want to like keep all your memory for whatever reason. But most people just stop and start them. You can create what they call AMIs, which allow you to like snapshot, like image the instance. So many of you might be familiar with the concept of golden images. And then you can basically like clone or copy that golden image and launch it as many times as your licensing will allow you to. So generating machine images is really easy on AWS. They do have a bunch of different family types. And I'm just going to warn you, you're going to have to read the documentation to find out what all these types are. For example, if it ends with a G, like it's an M6G, as you see there under general purpose, G stands for Gravitron. That is an ARM-based system, not an x86 64-based system. So it's using an ARM processor. Probably not going to work with a lot of your applications unless they're compiled for ARM. If it ends in like an A, for example, that's usually AMD. If it ends with an N, it's Nitro. I mean, you learn all this stuff after working with it for a while, but they're not going to test you on this. You do need to know the general classes, like there's the general purpose family, there's the compute optimized family, memory, storage, and then what they call accelerated computing. Accelerated computing, by the way, just has GPUs available for processing. So 3D rendering, that kind of thing. So you do have to generally know like the 5 family types. You don't have to memorize all the letters and stuff. Usually it's expected that you know like the first letter, like R is used for memory optimized or C is for compute. But they kind of gotten away from that because there's just too many instance types now. So one website that might be very useful to you if you ever have to make a decision around this is that if you go to a website, it used to be called EC2instances.info, and it's been renamed because a company bought this open source project. And it's called instances.vantage.sh. Notice that this is an easy EC2 instance comparison website. What this does is that you can pick your region. So I don't think GovCloud, oh, there it is. I stand corrected. There's GovCloud East, right? So I'm going to remove filters because I'm not sure why it's doing that filtering. Give me just 1 second. It takes a moment for it to refresh. There we go. All right, let's go to GovCloud East. All right, so GovCloud East, right? And let's say we're not necessarily going to mess with any of the pricing options. Let's say that someone comes to you and says, hey, I need a 16 processor system. You just type in 16 here. Then you get all your options that are available in US East, right? I'm sorry, GovCloud East. And so, for example, you'll see the R series, the M series, right? And let's say someone comes in and says, you know what? I need 64 gigs of RAM, which is a pretty standard setup. It's 4-to-1. Notice the M5 series, the M6s, these are the ones that show up. Now you're going to have to go look up what these G's and D's and N's mean, because they all mean something. The best way to do that, by the way, is just to look up AWS instance types. And you'll usually get the documentation. I'm gonna post that in the chat just as well. And when you're at this page, what will happen is that you'll see general purpose compute, blah, 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 blah. So let's go back over here. So this was the quadruple extra large, which I know the M series is general purpose. So I'm gonna stay on general purpose, and let's go back to this and see how it says M6A. Let's go take a look at the M6A. Guess what? This is an AMD processor. x86, totally fine, right? But now I'm like, well, what is the I? Well, the I is a Intel processor. Well, what's the G? Well, the G is what I was telling you, the ARM-based Gravitron processor. So just know that these letters all mean something. N, I think, is for Nitro, if I remember correctly. Neural networks, Nitro system. Yeah. So you have to look up these letters. There's just no way around it. But this website will help. EC2instances.info will allow you to find the size of system that you're looking for. And I joked earlier about there being a 448 processor system. There it is. Notice that this one has 24 terabytes of memory. Notice they're not publishing the price on that. I wonder why that is. Probably costs like $100 an hour or something. 16 virtual CPUs, by the way. Actually, you know what? Let's pick something smaller. Let's do an 8 by 32. I just want to be clear. See how it says like this is a T2 X large. Here's a T3A. Here's a T4G. These systems, by the way, this is like 30 cents an hour, 35 cents an hour. This one is unavailable.
Quick question on this.
Yeah, ask away, Jerome.
How would you know really how many processors you're gonna need? I mean, you have 448 processors. Good grief! How do you know you're gonna need 200 processors? How could you kind of gauge that?
So here's two cool things about this. One, you really won't know unless you do performance testing before you launch it. Even when the vendor says, "Hey, we can handle 10,000 connections with this set of hardware," they're not handling 10,000 of your connections. So honestly, no one really knows, which is typically why you have to load test or performance test your applications before you launch them to get a sense of what the per unit like value is. For example, I need 2/10 of a processor for every user, right? Or a gig of memory for like, I'm sorry, a meg of memory for every user. So you really won't know until you actually put it into production. And especially when you get a multi-layered system that has a bunch of microservices and databases, you really won't know until you get the system set up, you get everything monitored and orchestrated, and then you put load on the system and see how things flow. You just can't. That's the first answer to that question. The second thing, though, that's really cool is that let's say you come in here and you guess wrong. Let's say you come in here and someone says, hey, I need 16 processors and 64 gigs of RAM, which is pretty standard for like an API, a database system. And you come in here and you grab an M6A and you're like, you know what? I actually need, instead, I need 32 processors. And I might even need like 128 gigs of RAM because whatever. I know things are getting bigger, right? Notice I went from an M6A 4X large to an M6A 8X large. You can literally stop a system, resize it, and then start it back up, and it's at a new system. All your data is preserved. The only thing that needs to happen is the kernel now just adjusts to the fact that it has double the processor and double the memory. Doesn't cause any issues. Linux works fine with that. Windows works fine with that. So Gerald, just to say this is that the answer is that you won't know unless you do load testing, but even if you guess badly, you can upsize or downsize the system as you see fit if you need to.
Great, thanks.
Yeah. And you won't incur any data loss. In some cases, by the way, you can even change family types. So like I could go from an M6A to a 6, a C6, a compute instance. It's not going to cause any problems. You're going to retain your data. So as long as you're using EBS, so just for everybody who doesn't know this, EBS is the virtual hard drive service that works with EC2. As long as you're using an EBS backed system, you're not going to lose your data. You can upsize it and change it as you see fit. But the only way to really know is to do performance testing. Okay. Let's see. There was a question. Do we need to be concerned with on-demand or reserved instances? Of course. Billy, come on. In this new day and age, every single developer and every architect and every SRE, DevOps person, sysadmin, hell, even the Scrum Masters and the project managers are all now expected to code, no security, and you're expected to know how to do billing. So yeah, you got to know all this stuff. I'm just kidding. Kind of, right? Just to say this, it is actually everyone's job to be aware of security and billing. So that one I'm just going to tout because those are two harder things inside of cloud. Every single configuration toggle, every single design decision you make inside of AWS is either going to have a billing impact or a security impact, sometimes both, right? So since on-demand versus reserved is a kind of billing construct, where one is retail price, which is what on-demand is, and reserved instances are where you get a discount, but only if you get into a light contract with AWS. You do have to kind of like be cognizant of that. It's not really covered in detail here, but you have to be aware of what your app hosting platform is costing the company. So obviously a larger instance that's on demand is going to be more expensive than that same instance in reserve pricing. Okay. So you need to be concerned about it, but you don't need to be deep into it for the developer exam. Billy, they not only have spot instances, they've made spot instances so easy to use, and you can mix them with on-demand and reserved instances. So you can create these fleets, what they call a spot fleet of instances that will automatically show up and do work and disappear. And as long as your application is relatively stateless, it doesn't cause any problems. So spot instances are still around. By the time you leave on Wednesday, by the way, I'm going to leave you with some free published official AWS labs that are going to allow you to play with spot instances if you want to. So you'll have plenty of experience with that. Okay. We might even talk about it like in the next slide. So, so note that Amazon has a couple of different billing options if you want to use virtual machines. So this is what Billy was asking about. So on demand are the prices that you just saw here. So let me shrink this down just a little bit. I'm going to pick on a different family because it's easy to see it when I just choose a different family type. Hold on. There we go. All right. So let's sort this out by memory. So this is the T3 series, which is one of my favorite series for just proof of concepts, messing around. Why? Because they're so cheap. Look at these prices. 3 cents an hour, 6 cents an hour, 12. If you want an 8x32 system with, some limits on the processor, it's going to cost you about $0.25 an hour. Now, if you pay on demand for Linux for an unlicensed operating system, these are the prices. If you pay reserved, which means that you're either going to get into a year or a 3-year contract with AWS, you don't have to talk to them, by the way, you just commit to it. They're going to knock up to 70% off the price, but typically somewhere between 30 and 40% off the price. So notice here that if we look at the T3 2X large, it's about 40 cents, 39. And then it drops to $0.25. So it knocks about 14 cents off, which is, about 30 or 40%, right? So note that the reserve cost is basically a year or 3-year commitment, and you pay for that machine whether you turn it on or not. So AWS is going to get their money. Now, spot, notice there's no spot listing here. Spot pricing can get up to a 90% discount, but you've got to have an application that can withstand interruptions, like a web server. You got connections running through and the web server goes away. As long as you have a load balancer that can distribute that load to other systems, a web server can run as a spot instance, no issue. But here's the catch. Spot instances are basically Amazon giving you their unused infrastructure. So imagine this. It's February. Christmas rush is over. All the stuff has been returned. Amazon paid for, $1,000 worth of hardware in December, but now they're only getting $300 worth of use out of it because it's being 30% utilized. So Amazon has, all this extra capacity. So what happens is Amazon says, look, what are you willing to pay for that unused capacity that we have? And you put a bid in. And let's say that bid is like, hey, Amazon, normally I pay 40 cents an hour for that T3 extra large. I'll pay 20 cents. And so if Amazon has so much extra capacity that they lower their, like what they call their spot price, and you win the bid, you then get access to the machine and they'll put it into your account. It'll start up and it'll start doing whatever you've told it to do. That's you winning a spot bid. Now, here's the catch. If someone starts a bunch of on-demand requests for that same machine, Amazon's going to give you a 2-minute warning and they're going to take that machine away from you. So you can get up to a 90% discount, but you could also lose that box. You get a 2-minute warning, you got to write all your data out, and then they're going to shut it down. So just know that Amazon has made this super easy to do now. And I feel bad, Adam, for all those companies that help people do this, because Amazon's made this like ridiculously easy to do, especially with fleet mixing and stuff like that. So I love that they were doing it when it was really hard, but now it's like super easy. So just know that if you want to use spot instances, you have to have an application that can withstand interruption. But with on-demand and reserved EC2 instances, you own that box for as long as you've started it. So as long as you don't give it up, that box is yours. So on-demand, by the way, is full retail price. Reserved can be up to 70% off. Spot instances can be up to 90% off. But remember, with spot instances, they're very ephemeral, and you get a 2-minute warning when Amazon wants it back. With reserved and on-demand instances, Amazon will never take a box away from you unless the underlying hardware fails. So, or they need to purposely fail the underlying hardware, like retire it. There's also other reservation types inside of AWS. So there's also like compute savings plans. There's also dedicated instances, which are high security instances. Those are very expensive. Do note that Amazon charges you virtual machines based on either per second or per hour. Now it says all other OSs. That's technically no longer accurate. Amazon Linux, Ubuntu, MS SQL Server on Linux, they also do per second billing. And I want to say they converted Windows to per second billing as well. So I think it's only SUSE, Red Hat that now do per hour billing. Everything else, I think it does per second billing. Yeah, I think that's right. Okay, so that's all virtual machines. Okay, any questions about that? Because that was like, oh my God, Michael, we just went through some licensing options. Okay, so here's a few questions just to wake your brain up, because we're gonna take a break in a second. Which of these is the most expensive way to use virtual machines in AWS? Adam, the answer to your question is yes. Yeah, so by the way, Adam asked me, he said, if you spin up a Red Hat server for 1 minute, you get charged for a full hour. Yes. By the way, if it's a Mac machine, you get charged for 6 hours if you spin it up for 1 minute. So yeah, just, you got to know those little ins and outs, right? So on demand, by the way, is the answer for the question, which is what's the most expensive way to use AWS as far as like these options. Technically, just so you're aware, dedicated, which is a special no shared tenancy option, is technically the most expensive way to use AWS, but out of these three, on demand is the right answer. Okay, which of these requires your application to be able to write out all of its data within 2 minutes, but yet will give you a 90% discount if you can handle it? Okay, good. Spot instances, right? Spot instances are awesome, but you have to be able to orchestrate them. Not hard to do nowadays, right? Okay. So which of these, by the way, will allow you to spin the instance up and give it back? And the minute you give it back, you stop paying. That's right. You want to spin up an instance for 2 minutes and it's an unlicensed operating system, then yes, you can, it's on per second billing. You can just give it back, right? They're not going to charge you anything. Okay. Which of these, by the way, require you to commit to a year or 3 years with AWS? Yep. And just to be clear about that, there's a couple of different types of reservations or reserved instances. Some of them are more flexible than others, but you have to say exactly what operating system, what region, what availability zone you're going to run when you do a reserved instance. There's some flexibility with that with convertible instances, but just know that reserved is the 1 or 3 year commitment. The longer you commit and the more money you pay upfront, Amazon will push you to that like 72, 74% discount. So just know, the more money you give them now, the more of a discount they'll give you over the year or 3 years. It's a good model. So Justin, I believe that you can change the AZ if you're using a convertible instance, but for the most part, the answer is no. They want you to stay, if you're making a capacity reservation, which is what you're doing with that, they want you to stay in the same availability zone. But you can usually talk to your rep to get that shifted. But convertible instances, because there's standard reserved instances and there's convertible reserved instances. Convertible reserved instances will let you change sizes and other things about the reservation, but you don't get a deep a discount. So. Okay. So that was all about EC2. That was just virtual machines. That was all about the different sizes of virtual machines and all these other pieces. Other things to note is that this is about elastic load balancing. Elastic load balancing is pretty straightforward. This is a network device that acts as an entry point for like your website or your traffic, and it will distribute traffic out to whatever number of servers you have on the back end. By the way, if you want to run this across all 6 availability zones inside of Virginia, the load balancer will run across all the servers that are in all 6 availability zones. If you've got 3 availability zones, you can do that. But this device's job is to, 1, be highly scalable and highly redundant. So it looks like a single device, it's not. So it's already HA'd, even though it looks like a single endpoint. And what it does is it health checks all of the servers on the back end. So if you're looking at the example here, traffic's coming in here on the blue, and then what happens is that it gets routed to whatever servers are available to handle that traffic, and the responses come back through the load balancer, right? Because it's request response, blah, 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 for the most part. So if the load balancer sees that an instance is no longer in play, it will stop sending traffic to it and send that same traffic to another system. And it does this through a health check. So when you write applications, you need to have health checks in your application. And all it is an endpoint. That's all it is. So as an example, here's a health check where they're hitting monitor.php. You know, it'll be like www.catvideos.com/monitor.php. And what will happen is that the load balancer will talk to this every 10 seconds. It's going to expect a 200 because that's what you've told it to expect. And then here's what it does is it's going to talk to the database, check to see if the disk is full, call the third parties, and then it's going to return an okay. Otherwise, it's going to say, hey, 503 service is unavailable. As the developer for the application, you get to write and control this. So it's important that you have this instrumented into your application so that someone can tell not just about how that application is doing, but all other associated apps for that front end, how they're doing. Now, you can also make it so that instead of sending the traffic to random servers, you can make a user session persist on a single server. This is not recommended because it ties the user's session to that server. Instead, as a developer, it's recommended that you use some kind of session cache. It could be DynamoDB. It could be, Redis or Memcache using Elasticache. Doesn't really matter. But the session cache needs to persist outside of the application. That way, if the application crashes and another application has to take the session from the user, they're going to go check the session cache and find out whether the user's authenticated, what state where they're in. Is there a shopping cart? Where is that located? Are there items in the shopping cart? Like, if sessions are stored on the actual system that's running that application, if that system crashes, then the session data is gone. Users got to log back in. They lost all their objects. We don't want that. That's not best practice for coding with AWS, or really for anybody. So you can use an SQL database if you want for that. Like you could use DynamoDB. You could use Redis. Most people don't use an RDBMS like Postgres or whatever, because they typically don't scale that well for that kind of transaction. But if your sessions are low enough, you could get away with it. So we were talking about virtual machines, and now we're talking about load balancers. And what they're just highlighting is that if you use a distributed load balancer to distribute traffic, make sure that you're externalizing your sessions off of the application platform. That way, any application can pick up the user session at any time. All right, last but not least is auto scaling. Now, you need to know about auto scaling because auto scaling is the secret sauce that makes virtual machines not horrible on AWS. Because otherwise, honestly, if you just spin up virtual machines on AWS the way you do in your data center, this just becomes expensive data center 2.0. That's all it is at that point. It's not what AWS is designed for. Elasticity is the name of the game. What this means is that you're going to add virtual machines and reduce virtual machines based on your user load or capacity. So for example, it's 3 o'clock in the morning on a Saturday and nobody's on your website, then scale down to business continuity minimums. In other words, if you need to run 2 servers because the business doesn't want to run any less than 2 servers just in case there's a hardware failure, then you set that up with your auto scaling to reduce down to 2 servers. If on Monday at 9 a.m. you require 100 servers, then you set auto scaling to just spin up 100 boxes at 8:30 a.m. on Monday morning. That's all. And there's a couple of different ways to do this, by the way. There's manual scaling, where you turn the dial on the number of virtual machines you're running at any given time. There's scheduled, where you're like, hey, it's 8:30 on Monday. Let's add 99 boxes, or 98, right? And there's dynamic scaling, which says, hey, you know what? If latency falls below 100 milliseconds, I want you to add 10 boxes. Oh, did it fall below 10 again? But below 100 milliseconds again? Add another 10 boxes. Wait, latency is down to 20 milliseconds? Take 10 boxes away. Delete them, because we have too many boxes if we're down to 20 milliseconds. Although I don't know that anybody would complain about being that fast, but you might break the bank, so got to be aware of that, right? So just know that auto scaling is like the secret sauce with a load balancer that allows you to dynamically add and reduce the number of EC2 virtual machines that you are running your application. That trifecta of basically CloudWatch, and actually that is technically accurate. CloudWatch, which is the monitoring system, which watches all these metrics. The load balancer, which does the load distribution across all the virtual machines, and auto scaling allow you to elastically contract and expand your application. So this is extremely important for virtual machines. If you are going to use virtual machines, even if it's non-production, auto scaling can be a great friend here. For example, let's say you're running a Jenkins server, and if it crashes, all your developer work stops. Put it into an auto scaling group of 1. If it crashes, auto scaling will relaunch it. And assuming you have proper backups and orchestration, it'll relaunch that Jenkins box so it comes back up. And if you put a load balancer in front of it, then the URL won't change. So just know, using this trifecta of elastic load balancing with auto scaling with CloudWatch is great for any non-production or production environment, especially if it has to stay up, right? Questions of any type about any of these 3 services?
Did you say it's only good for non-production environment, or production or non-production environment?
No, Gerald, it's good for all
Okay.
of them. Yeah. For non-production environments, because especially when developers are going to be impacted, it's great for those systems. It's great for production environments because obviously, you want to be able to scale. So it's great for both. All right, let's do a knowledge check, and then we're going to take a break, because hopefully I burned your brains down just a little bit. Okay, here's the check. Is this true or false? Traditional monolithic architectures are harder to scale. Now, I agree with that. I mean, technically that's true. And I see a bunch of you putting true, and that's fabulous, right? But I just want to say this is that we do actually know how to scale traditional monolithic architectures. You just add another virtual machine, right? It's not hard. I think a better question would be, are they efficient at scaling? And they're not efficient at scaling. Because, for example, I'll just give you an example. Let's take Netflix, for example. We have a presentation layer. We've got customer billing. We got customer profile. We've got the streaming service. We got a ton of recommendation pieces. There's like 30 microservices just for the front end of Netflix alone. If the billing information gets overloaded because American Express has a data breach and they had to issue 100,000 new cards, Netflix is going to all of a sudden get hotspotted on their billing information because a bunch of their customers are going to update that at one time. If that's a monolithic architecture, you now have to launch a bunch of virtual machines or instances of your application in order to just scale the billing information, not the presentation layer, not the recommender or whatever that's built into that code base. But if it's a microservice, that means there's 30 microservices there. The only one you need to scale is the billing service. The recommenders and all the others are not going to get heavy hit because you just need to scale that billing application. You don't need to scale the recommenders or the presentation layer or the customer profile. You don't have to scale any of that stuff. So I take a little bit of issue with that. It should say traditional monolithic architectures are more efficient at scaling. They're not harder to scale. They're more efficient. All right, second one. Reserved instances are unused Amazon EC2 capacity. Supply and demand for the instances determine the price you pay. Okay, so not only just give me false, because I see false there. What are they talking about there? Which of the billing types for EC2 are they talking about? Yeah, they're talking about spot instances, so it's perfect. Right, so out of the three, you got on demand, reserved, and spot. Spot is the one that's actually Amazon's extra unused capacity. Okay, with auto scaling, you can specify the desired capacity, which ensures that your group has this many instances. Do you think that you actually have the ability to tell them what your min, your max, and what you want is? Can you do that inside of auto scaling? Because I didn't talk about this, actually. I didn't mention it. Let's go back and take a look for just a second. So here's the cool thing. This one's just a gimme because I didn't explain this, right? Is that you can set your minimum number of instances. So the minimum number it can fall down to. You can set your maximum. Why would you set a maximum? Because what if somebody starts denial of servicing your system and is trying to get you to bankrupt yourself? You're not going to spin up 1,000 instances, right? Maybe. But the other thing is that you can set your desired. You can say, look, this is where I want to start. I want to start at 10. I can go as low as 2. I can go as high as 100, right? So just to give that one, because I didn't explain that very well. With auto scaling, you can't actually set your desired capacity. And that's just like where you want to start at, right? So it's going to make sure that typically it's going to keep you at that desired number unless your rules, like for auto scaling, require you to go either above or below it. So, right. So again, it's kind of where you start at. Okay. AWS recommends replicating across availability zones for resiliency. Do they want you to use more than one availability zone, or do they want you to use only one? At a minimum, AWS recommends that you use multiple availability zones inside of a region. Now, if your requirements require it, you need DR, like good DR, they're going to tell you to go multi-region. But at a minimum, AWS is like, please always use more than one AZ, because unless it's a global outage, which oddly enough hadn't really happened for a couple of years until recently, AWS had some really public and really messy outages. They're only going to have a failure across one availability zone. Like one of the 3 failures they had in the last 60 days was just one availability zone, which was a little weird because Amazon like just really like harps on this. Please do not use just one availability zone unless it's something that you're okay with going down. because if they have a power failure or a cooling failure, it's going to happen along one availability zone, not two, typically. It's funny, Amazon, like probably once every 5 years, once every 4 years, it seems like has a global outage. And boy, they're either like one AZ is down or all of it's down, you know? So it's really fascinating. All right, so true. All right, you can't miss this next one because I took issue with this statement, right? So one benefit of cloud computing is that you stop guessing capacity. Is that an official statement that AWS has about a benefit of cloud computing? Is that true or false? Is that one of their official statements about cloud computing? Yeah, remember I had a problem with it. It was like changed it and said you can fix your bad guesses, right? But it is actually true. Technically, it is one of the 6 official advantages of cloud computing. Can anyone name any of the other like official like benefits of cloud computing according to AWS? Data centers, capital expense versus variable. That's exactly right. Good. Obviously, innovation and agility, right? Which probably fits into scalability. Or go global in minutes, which Adam, that may be also what you were thinking of, is the go global minutes. You can scale quickly, right? I'm sure there's another one and I forgot it actually. All right. So this one is something I probably didn't talk about. So I'm just going to kind of give you this one as well, is that the reason they don't like sticky sessions is that it kills your scalability, right? It forces the user to relog back in when a session ends on a piece of hardware, like where the application is hosted. And so that's why they were asking you to externalize your session information out to another system, so that if the application crashes, another application can just get the session information. So that one, again, is another gimme. It's like, just make sure that sticky sessions are not a great way to increase your application's scalability, because it
Could you
ties the
explain what that is
user
again?
to that session.
Could you review that one again, sticky sessions? I think I missed something there in translation.
Yeah, so sorry, went too far here. Yeah, so if sticky sessions basically say that we're going to send the user repeatedly to the same backend box. So the load balancer is going to tie a user, like an IP import, back to a particular box. And every time that user comes in, they're going to go to the same physical system. The problem is if that box crashes, that user session goes away because it only lives on that physical server, or virtual server in this case. So sticky sessions are not a recommended method for creating like persistence in session information, because that box is at risk. So Amazon's advocacy, which is, I think, industry advocacy, is that store your session information on an external cache like DynamoDB or some other database. That way, when a new user comes in or an old user comes in, instead of having to go to the same box to get their session, a new box can just grab the session from an external data store like DynamoDB. And this is kind of a known pattern, because by doing that, you can replace all of your systems at the application layer at any point in time, and you don't have to worry about creating a bad user experience for the users. Any questions there?
Okay, I got it. Thanks.
Cool. Let's see. The difference between IaaS, PaaS, and SaaS. Let's go back for a second. Okay. So Justin, the difference here that we're kind of touching on is that infrastructure as a service means that you have raw control over the infrastructure, meaning you can log into an operating system, as an example. That, by the way, is considered the most control, but the most responsibility. So that's what infrastructure as a service is, right? You can control the networking, you can control the storage, the disk, all those other pieces, and you get to control the operating system, but it also means you're responsible for patching the operating system. Platform as a service is when you're not really worried so much about the operating system, but you're going to run some kind of application on top of it, and you want the ability to control and manipulate that application. For example, Postgres. Let's say you want to be able to log into the database, change a bunch of aspects to the database. That's platform as a service. That means you're consuming some kind of application on top of it, but it's not like a Gmail application. It's not like a consumer application. It's an infrastructure application. Because I think you agree that your mom or your dad, I don't know, maybe they're in technology, so I'm not judging. They're not going to run Postgres themselves, right? Now, they might want access to a web-based applications that gives them, active COVID cases in their county. That's a web application. That's a SaaS. But if they're going to go into the database directly and manipulate that, that would be a PaaS. And if they want to log into the operating system because they wanted to tune the performance of the operating system so the database ran faster, that would be infrastructure as a service. So those are the distinctions, is that a PaaS is typically an infrastructure application that you now have platform access to, like a Kafka or a MongoDB. But the general rule of thumb is that, for my definition, is that a SaaS is something that pretty much a non-technical person would use, a web application, right? Something along those lines. But everything from a PaaS to an infrastructure as a service is going to be something that only an engineer would use, typically. Does that help, Jess?
Yes, thank you.
Yeah, good. And that probably helped a bunch of other people as well. So thank you for asking. Okay. Scrolling down. All right, so that is the end of that particular module, and it is 10 after 10. So here's what I'm going to do. I'm going to stop recording.